نبدأ بأخونا محمد شعبان. أنا راح أقرأ بالإنجليزي من الموجود، وهو موجود أصلا معكم بالمنشور حسب ما وثائق المؤتمر. Has more than 23 years of experience in irrigation and agricultural development, water resources management, water strategy, and institutional reform of the water sector, institutional support for the irrigation management transfer, water use associations, irrigation system design, wastewater reuse in irrigated agriculture, training and capacity building, social marketing, and farmers' behavior studies. Also, he worked with numerous international funded projects. The latest is with the USAID in Jordan. And also in many countries in Jordan, Yemen, Saudi Arabia, Moldova, and Iraq. I will give him the floor to give us his presentation. I will give each of our experts 15 minutes to talk, and I think we will open the discussion by the end of all the sessions so that you can formulate your questions according to the collective presentations in the area. So, please.
Thank you, Madam Chair. Sometimes it's good to be the first one, so you are the luckiest to start the presentation. I'm here going to present a study carried by the Water Management Initiative project, and I'm presenting it on behalf of my colleagues in the project. And it happens that the colleagues are on the panel now with me, in addition to an expert who brought the technology here that we use in the determination of the losses in the canal. To start with, I will give a background about King Abdullah Canal. It is a 110 kilometer long concrete lined canal built in stages. Started in 1957 and the first stage in 1961 to 1964, and it was completed in 1978. The head discharge capacity of 14.5 meter cube per second. It's divided into two parts. Actually, this is the division according to GVA. The first 65 kilometer long, it carry only fresh water because it uses for domestic and irrigation purposes. But the other part, which is the 45 kilometer long, it carry blended water from King Talal Dam. Average inflow is about 180 million cubic meter, 120 in the upper part or the northern part, and around 60 million cubic meter in average for the southern part, controlled by cross regulators, or we call them check gates. And it is also has SCADA system along the canal. The objective of the study is to measure all losses in the canal, including the physical, the unmetered or illegal losses, and the evaporation, and also to rank these losses for the sections according to the efficiency of each section, and to recommend section for rehabilitation. What we use, the approach used in this study is the first we divide the canal into sections. So we study the losses in each section, and the section agreed to be the distance between two check gates. As you can see in the your right in the screen, that we have different check gates on this map, and the distance between two check gates, we consider them as one section, and we apply the water balance equation, which is the losses. It is equal the input minus output minus evaporation minus the change in the storage in that particular section. Also, we use two approaches actually in the determination, whether fast flow that we start the measurement at the beginning of the check gate and go directly to the end of the section and take the measurement of the flow. Then we find that there is this approach has some problems, actually inaccurate data. So we follow the other approach, which is follow the water approach. That we took the velocity and then we take the measurement and wait for the same parcel of water to reach the end of the section, and then we took the measurement again for the flow. The technology we use, it is a new technology introduced to Jordan. We use this M9, the Sontic M9 device, which has it has 9 beams, and it is both based down-looking profiler. Anyone interested in that device, it is found in the booth of the WMI in the conference here. And it has a proven state-of-the-art acoustic Doppler velocity combined with a window-based software package. This is the software that we use. It comes with the instrument, and we use it in our calculation, in our measurements. In addition to the first instrument, we use another one called Sontic IQ. This one used to measure the flow, continuous flow in the canal. The concept is to fix this device in the bottom of the canal and to take continuous measurement of the flow over more 24 hours and more. But what we use in our measurement is to take it for 24 hours. We use 3 sensors actually, but at the beginning of the check gate, at the end, and the other one. So at each 24 hour, we measure 2 sections in the canal. Here also, we adapt this instrument to our condition because we couldn't fix it in the bottom of the canal. So we built a structure, a steel structure, so we put that instrument in the canal. Here is how we use this spot in the canal. We put ropes in the 2 sides of the canal so we can pull this device, this Sontic M9, to measure the flow, instantaneous flow in the canal. Here is for the IQ. It was very difficult how to fix it in the middle of the canal and to keep the batteries under the water. So we try to adapt this instrument to our condition, our local condition, and we manage actually to make the measurement. It was very hard work to do that. If you can see the green rope here, that after we fix the instrument inside the canal, we take the other ropes and we hide this one under the water, so the next day we can find the instrument and pull it out. What we did in this study, that we took more than 1,300 instantaneous M9 discharge measurement. At each site, we took 6 measurements. It's actually, we want to guarantee that 4 of the 6 that they are very close, so to be used in our calculations. What we did also, that we repeat the measurements during July and October, and even in the southern part, we use also in April, we make some measurements. When we have to measure the inputs and the outputs from the canal, if we pass by any pump station or any outlet in the canal, we took the measurement before and after, so to have accurate measurements throughout the canal. Also for the IQ, we more than 14,000 5 minutes measurement were taken by the IQ during October and April. We face some problems in the measurement because of the sediments in the canal and some of the trash that cover the sensors. So we end up of repeating some of the measurements after the quality control check the next day. And we face some problems even with the battery, some water leakage in the batteries. So we faced many problems and tried to solve it in the field. What also we did that we trained 7 people from GVA on everything. It is actually, they helped us in the measurement. They know how to use the instrument, how to use the software even, and the troubleshooting of all the problems that we face in the problem. We were in the field hand by hand. So we can ensure the sustainability of using this instrument even after the Water Management Initiative project ended, that it will remain here for GVA and for Jordan to be used. So 7 people were trained on that, and even we addressed many issues in the measurement of this instrument, and we teach them how to overcome all of these things. We face a problem of for example, the heat. The dongle there, the transmission of the data interrupted because of the heat. We contacted the company, we replaced the dongle, and actually we noticed that we made some measurements while we are in the car under the conditions, so we can achieve the required results here. To come back to the results, what we found that on the first 65 kilometers in the canal, that the total losses in the canal was 24.5%, divided into 1% as evaporation, around 11% as constant or physical losses, while around 14% as unmetered or illegal use. The total water losses for the southern part of the canal accumulate for 38.1%, 0.6 of them as evaporation, 14.5 constant, and 23 as unmetered or illegal abstraction. Here also, we try, as we said, the objective of the study is to rank these losses according to the sections. So we have, as you can see in the first map here in the GIS, that we put the total losses per kilometer, because as I mentioned in the beginning, that we took the section as the distance between 2 check gates, and the check gates were not equal in distance. So we prefer to have a fixed reference, which is the 1 kilometer distance, and we rank the losses in the canal. So if you can see here, the check gates here, and if we go to the one in the middle, it is the physical losses. So we rank the physical losses. It's not necessary to have the red color, which is the hottest spot in the losses as a total losses. We have the physical and we have the illegal losses. Actually, this helped GVA to identify areas where there are potential for saving and for controlling the sections in the canal. The recommended measure from this study is to refurbish the lining of the sections that show high physical losses, and also to refine the policies and regulation actually to reduce the illegal abstraction from the canal. Another thing is to repair the SCADA system. Actually, we face some problems in the SCADA system that not all the stations of the SCADA system were working. So it is a recommendation to fix this SCADA system with GVA, and to systematically remove the vegetation from the canal. This made a lot of physical problems to the canal because of the roots of the plants. So the removing of this vegetation cover is very important. And as a next step, we have two main recommendations from the study, whether to fix the parts or the sections of the canal that show high physical losses due to old age of the canal, or there is a recommendation from the project is to convert the conveyance system of the northern part, which is the first 65 kilometers from the canal, from an open nature to be as a pipeline. And the next step that WMI will try to help GVA and the decision maker in GVA and the Ministry of Water and Irrigation to take the appropriate decision by conducting a pre-feasibility study about the technical implication of converting the canal into pipe, and also to make a cost analysis of this option so GVA can take their right decision on that. Thank you very much.
Thank you, Mr. Shaban, for this very fruitful presentation. And I can tell that the findings help the water sector to identify areas that are critical to address them, either in the physical losses or the illegal losses, or even in closing the pipeline, closing the canal into a pipeline that we are also keen to study and to see if it's feasible again. So thank you very much. Our next expert is the engineer Qais Awais. Qais Awais, besides what he wrote as a very modest bio in the papers of the Aqua Conference, I know him as a colleague who have been very, very professional. All the years that I've known him, like more than 30 years, he've never had any enemy in the water sector, or everybody loved him. So it's not only his experience, his also attributes that I should talk about. So Engineer Awais, now he has more than 35 years experience in the water resources management, transboundary water dialogues, irrigation organizations, water strategy, institutional reform of the water sector, drought management and design of water balances, decentralization and participatory irrigation management through the Water Use Association concept, wastewater reuse in irrigated agriculture. He holds a high diploma in highways and traffic engineering from the Faculty of Engineering, University of Jordan, and a BSc from the Faculty of Engineering, Asyut University in Egypt. Also, he will talk to us about the reform. Yes. So please, as we discussed, we will give 15 minutes for each presentation, and we will open the discussion by the end of the session. Thank you. Can you help in loading the presentation? فكرت انها هاي مش من هون. كيف بدنا نعمل كليك على البرزنتيشن؟ هذه بدي هاي.